welcome to the Backyard Professor Math videos. I'm going to carry on with these positive and negative numbers with you, and then I'm going to get to the ideas of absolute value, hopefully in this video. Hopefully I can cover it all. And as we learn the rules and learn how to manipulate because of the various operations we can do on these numbers, isn't it astonishing the various ways we can manipulate numbers to figure out the real world? This is the beautiful part of math that I'm really enjoying right now. The idea here is really quite simple. We have a double negative. We've shown you some positives and negatives. If we were given 5 minus a minus 2, the idea here with the double negative, the best way I learned it that really seriously helps is the enemy of my enemy is my friend. A double negative, what you do is you negate the negative. And therefore this becomes a simple addition. 5 minus a minus 2 becomes 5 plus 2, which gives us 7. And the reason why is because 1 and negative 1, 4 and negative 4, 18 and negative 18, these are all opposites. Every time you add an opposite, you get 0. Every one of these equals 0. And it is based on the direction of movement. And so this idea makes the double negatives much easier. When we get them in the equations, we will see that the double negatives are really not a problem in any manner. Now, what happens if we have multiple terms? Let's say we have negative 3 plus 5 minus 6 plus negative 3 minus 2 plus 4. I mean, equations can get great big, long, and hairy. All you do is you think of the number line. You're beginning at negative 3 plus 5. 5 is the larger number absolute value-wise, so it's going to be a positive answer between these two. This is simply 2. You can rearrange negative 3 plus 5 to 5 minus 3. That's all you're doing, is you're subtracting, or 5 plus a negative 3. And that's why that value is 2. That makes perfect sense. And then you have 2, and you're going to subtract 6. Well, that's a 2 plus a negative 6. The 6 is the larger number, so you know that part of the answer is going to be negative. So we're moving from the left to the right. We're going to systematically do this. So we know this is going to be a negative 4. So at this point we have a negative 4, I'll go ahead and write it, a negative 4 plus a negative 3, which is a negative 7. And then we have a subtract 2, which is a plus negative 2, so this becomes a negative 9, and then we add 4, so now we're going back to the right from negative 9 minus 4, which is plus a negative, which is a plus 4, which equals a negative 5. So that's how you do it. You start from left to right, and you just take into account all of the negatives and all of the positives, and you work the equation that way. Very simple, very easy to do, fun to do. When we multiply terms, let's say we have 3 times 2 times negative 4. And we'll find many equations where we multiply just hundreds and hundreds of items. 3 minus 2 is just 6. And 6 times a negative 4 equals a negative 24. When you multiply positives and negatives, a positive times a positive is a positive. A negative times a negative is a negative. And a negative times a positive is a A negative times a negative is a positive, and a negative times a positive is a negative. So if you have like signs, it's going to be positive when you're multiplying. When you have like signs, even though they're both negative, when you're multiplying, it's going to be a positive. And it's only when you have unlike signs in multiplication that you end up having the negative. And let me show you how this works. This is one reason why I wanted to move up on the board, because I'm going to write this just a little smaller. So we have 3 times 2 times negative 4. And we have 3 times negative 2 times negative 4. And we have negative 3 times negative 2 times negative 4. So there's 3 different ways to view this to see how this is understood. 3 times 2 is 6, times negative 4 is negative 24. That will be a negative. 3 times negative 2 is negative 6, times negative 4 equals 24. And negative 3 times negative 2 is positive 6, times negative 4 is negative 24. The thing you want to see here is when we have an even number of negatives, it's going to be positive. If you have an odd number of negatives, it's going to be negative. Here we only have one negative in the equation, and it comes out to be negative. Here we have 3 negatives, so we know because there's an odd number of negatives, it'll be negative. And it's that simple. You don't have to worry about, oh my gosh, how am I going to distinguish this? Count how many negatives or positives there are, and that will determine whether your answer is positive or negative. It's that simple. It's so easy, it's silly in some respects. It's the same thing with dividing. When we divide positives and negatives, let's say we have 3/2. This equals 1 and 1/2, right? 2 into 3 goes 1 with a 1 remainder in the numerator, and you bring over your denominator to the 2. If you have a negative 3/2, this equals a negative, this equals a negative 1/2. If you have a 3 negative halves, this also equals a negative 1/2. And if you have a negative 3 over a negative 2, this equals a positive 1 1/2. The reason is the exact same reasoning as with multiplication. These are positives, therefore the answer is positive. We have one negative here, so this is going to be negative. We have one negative, an odd number, so it's going to be negative. We have 2 negatives, which is an even number of negatives in the fraction, but it will be positive. A positive times a positive is a positive. A positive times a negative is a negative, and a negative divided by a negative is always going to be a positive. The exact same rule applies with division as it does with multiplication, and that makes it nice. That'll make it easy so that we don't have to worry about memorizing so much stuff. There's a little bit to memorize, but not too bad. Not too bad. Now, when we do a 4 minus 3, this is the exact same thing as doing 4 plus negative 3. 4 minus 3, you begin at 4 over here on the number line, and you bounce over until you get to negative 3. You're going to the left. With 4 plus negative 3, you start at 4, and you're going to add negative 3 to where you get. It's both the same thing. That equals 1, and that equals 1. Because the ultimate value between 4 and 3 is just 1. And since the positive is the larger 4, the answer is going to be positive. See, that's not too difficult to understand, is it? And we will get used to this as we work equations, and we are going to start working some equations. We've gotten enough information on how to do these that we really are going to begin to put them together in equations. Now, absolute value is easy. There's very little that is easier than absolute value. The absolute value of 4 is just 4. The absolute value signs are lines to either side of the number. Try to make them a little bit bigger so that they don't look like ones, because those are not ones. Those are simply absolute value bars. With absolute value, even with a negative 4, your absolute value is going to be positive 4. And the reason why is because, well, and the absolute value of 0 is just 0. Because absolute value cares about how far away from 0 you are. It's not about the positive or negative sign, it's how far away are you from 0. And on the number line, -1, -2, I'll just do this with the first few negatives. Whoops. Those are positives, sorry. -2, 1, 0, and then 1 and 2. The absolute value of 2 is just 2 spaces from 0. And the absolute value of -2, the absolute value of -2 is also 2, because it's just 2 places from 0. That's what absolute value is. How far away from 0 are you? Absolute value doesn't care what direction you're going. It cares how far away you are from 0. That's why it's always positive. Even with a negative in there, absolute value is always positive. There is one exception that I'll show you. And the exception is very easy. Whenever you see anything in an absolute value bar, the absolute value of x is x. The absolute value of -x is x. The exception is if there's a negative on the outside of the absolute value bars. The absolute value of what is inside those bars is always positive, regardless of the sign. Inside. If you have it outside, though, it does make that negative, because that's negating the entire equation there. Does that make sense? Anything inside the absolute value bars gives you a complete positive. Okay, let's move on to, I'm going to rapid fire do this on purpose, because once we learn the various operations, then we will have lots of practice. Math is one of those subjects where you don't learn by just reading about it. We actually do the mathematics, and that's what we'll get to where we're doing here just shortly. I want to show you some exponents. Exponents are very simple. The idea of an exponent is x squared. You have the base, which is this part, and you have the exponent, which is this little number up to the right-hand corner. This number is simply telling you how many times you're going to multiply the main number, the base number. So x squared is simply telling you you're going to multiply x times x. If this was x to the 4th, we would be multiplying x times x times x times x. We would have 4 x's. If it is y to the 3rd, you have 3 y's. Y times y times y. It's that simple. With numbers, it is the exact same thing. You just multiply the main number by however many times this little number shows you. 3 to the 3rd equals 3 times 3 times 3, which is equal, 3 times 3 is 9, times 3 is 27. You can see how fast an exponent will get large, can't you? 2 to the 4th, now remember, 2 to the 4th, this is not 2 times 4 equals 8. That is not what this is. What this is telling you is you're going to multiply 2 4 times by 2 itself. It's 2 times 2 times 2 times 2, which is 4 times 2 is 8 times 2 is 16. See how fast that builds up? 3 cubed equals 27. That's fascinating. And then y cubed, of course, equals y cubed. So you can, this applies, exponents applies, of course, to variables without ever knowing what the variable value is. You can see that, right? If we have m squared n squared, that is simply telling us that we have two m's multiplied by themselves and two n's multiplied by themselves. You see how that works? So it works with variables and it works with numbers also. Now, one interesting exception to this, and we will have recourse to do a lot of exponents because scientific notation uses exponents, and it allows us to calculate very huge numbers and very, very, very tiny numbers really, really fast. 1 to the 0. What would you think that is? 1 to the 0 is just 1. 1 to the 1 is just 1. Why no difference? Let me explain this. 2 to the 0 is just 1. Whereas 2 to the first is 2. It's the number itself. Do you see why? Any number to the 0 power is always equal to 1. And any number to the first power is just that number. So any number you have, if you have 13 to the 0, that's just 1. If you have 13 to the 1 power, that's just 13. This works with any number under the sun. Why is this? I want to show you why, because the explanation is really excellent. At first, this seems counterintuitive. You would think, well, 2 times 0 is 0. You're not multiplying 2 times 0. You're saying that there are no 2's there. So it's 1. Here you're saying there is 1 2 there. So it's just 2. Let me show you the logic here. This is one of the things. Math is an argument. And we want to prove our argument. So let me show you why they have figured out this is so. 7 to the 4th equals 7 times 7 times 7 times 7, which equals 2401. 7 to the 3rd equals 7 times 7 times 7, which equals 343. 7 to the 2nd equals 7 times 7, which equals 49. 7 to the 1st equals 7, and therefore we would say 7 to the 0 equals 7 to the 1st divided by 7, which equals 1. And when we see this, we go 7 to the 0, I wrote this down so I would get this right, is 7 to the 1st divided by 7, which equals 7, because 7 to the 1st is just 7, 7 divided by 7, which just equals 1. And this is the mathematical rationale for any number to the 0 power being just 1. That's fascinating. That'll be very important to know when we want to begin to simplify some equations and we see that we have these exponents with 0 power, or we can take an exponent to the 0 power. We'll be able to manipulate that so that we can do a 0 power. When a number, so that's basically, let me do some addition. When a number is raised to a power and you multiply the number raised to a different power, what is this expression telling us? First, 2 to the third is 2 times 2 times 2. And we're multiplying this number by 2 times 2, 2 squared. It says you have 2 2's you're going to multiply. This says you have 3 2's you're going to multiply, right? Count the number of 2's here. 1, 2, 3, 4, 5. We're going to multiply 2 5 times. Look at the exponents. You have a 3 and you have a 2. Again, 5 2's. So that this becomes 2 to the 3 plus 2 power. When we're multiplying numbers together with exponents, the same base with different exponents, we add the exponents. This equals 2 to the 5th. And that makes perfectly logical sense because we have 5 2's, which this is 5 2's. 3, 4, 5. We have 5 2's with that. It works the same with any number. If we have 6 to the 5th times 6 to the 10th, this is going to equal 6 to the 5 plus 10. You add the exponents, and that simply goes to 6 to the 15th, which is an incredibly huge, huge number. It's not 6 times 15, it's 6. It's 15 6's all the way out. And each one multiplied to itself. This is how multiplying exponents together works. It's a great technique. We will have lots of practice with these, I guarantee you. You can work these and invent your own equation and have a calculator with you to test whether your calculation is right. Now, what if we have a number that's raised to a power and this expression is raised to a power? What do you do now? Let me show you exactly what this expression is saying. This says 2 cubed. So you know we're going to have 2 times 2 times 2 for this part of the expression, right? 2 cubed is 3 2's multiplied. But now the entire expression you have to do twice. So this is another 2 times 2 times 2. This is this. You have 2 sets of 3 2's. Count them off. 1, 2, 3, 4, 5, 6 2's. When you look at the exponents, 2 times 3. You multiply the exponents so that this becomes 2 to the 6th, and you drop your parenthesis because you've multiplied the 2 exponents. And this number is sorry, I wrote 6's, I meant 2's. Got carried away there. This number has 6 2's exactly like this number has 6 2's. So when you have a number raised to a power and then that entire expression in parenthesis, they'll put it in parenthesis, when that is raised to a power, then you multiply the exponents. Before, if we had 2 to the 3rd times 2 squared, this equals, we add the exponents here. This equals 2 to the 5th. See how that works? It's a very interesting and important distinction to make in how to multiply exponents. With that idea in mind, as we begin to work equations, we will easily begin to master these techniques, these rules as it were. And now we need to look at division. What if we have 2 to the 5th over 2 to the 3rd? Now this is saying this is 2 times 2 times 2 times 2 times 2. We have 5 2's. This one is saying we have 3 2's. 2 to the 3rd means we're going to multiply 3 2's. 2 to the 5th means we're going to have 5 2's. Notice what you can do here. Because you're in a fraction, you can cancel some 2's. What this is doing is, this 2 will cancel with that one, that 2 will cancel with that one, that 2 will cancel with that one, and what are you left over with? You're left over with 2 to the 2nd. So the rule when we're dividing exponents is we have 2 to the 5th over 2 to the 3rd. This is equal to 2 to 5 minus 3, which equals 2 to the 2nd. We had 5 2's on top. We subtracted the 3 2's underneath by canceling. We were left with 2 2's, which equals 2 to the 2nd. So the simple mathematical rule is, whenever we're having exponents that are divided, you subtract the bottom exponent from the top. That is really kind of a cool thing, isn't it? So that's that part real quick. And again, we will have plenty of time to work through. I'm giving you all the rules. Now we're going to start practicing a lot of the mathematics to show how these work really, really well. I think I've done the divide, multiply, add. Oh, and it's the... Okay, what about negative exponents? I believe I've got negative exponents in here. No, I don't, but I know what they're about. A negative exponent, 3 to the negative 3, let's say. This is equivalent to 1 over 3 to the 3rd. You put the 3 in the denominator, the 3 to the 3rd in the denominator, and drop the negative sign. This is how this works. If we have 5 to the negative 4th, this equals 1 over 5 to the 4th. It becomes the denominator of a fraction with a 1, and you drop the negative sign to a positive 4. That's how negative exponents are dealt with. And we want to begin with simple algebra expressions. We don't want to get running before we can walk. So I'm going to practice in the next video. I'm going to practice some very simple. We're going to evaluate some expressions, and then we're going to do some exponent practice and with positive and negative exponents. So happy calculating. Have a great life, and I will see you in the next video.